Good morning, my dear students. Hope you are doing well. Today I'm going to continue the explanation of Chapter 11, Carboxylic Acids and Derivatives. The objectives that you will learn during this session are two. The first one, identify some physical properties of carboxylic acids. The second one, identify some chemical reactions of carboxylic acids. Let us begin with the first objective, identify some physical properties of carboxylic acids. The first one, carboxylic monoacids are liquids or solids at room temperature. The second property is that their boiling point increases generally with the increase of their molecular mass. The third one is that the first four acids are miscible with water in all proportions. What do we mean by miscible? When two liquids dissolve in each other in all proportions. So the solubility in water of acids decreases as the number of carbon atoms in the chain increases. Here we are going to summarize the physical properties of carboxylic acids in the following table. Examine the table well. As you see here, the number of carbon atoms increases. On one hand, the boiling point of the carboxylic acid increases. On the other hand, the solubility decreases. So, as you see here, the first four carboxylic acids are very soluble in water. Then its solubility decreases as the number of carbon atoms increases. And as you see in palmitic acid, the number of carbon atoms is 16, so this carboxylic acid is insoluble in water. Now the question, why the boiling point of carboxylic acid is the highest compared to alcohol and aldehyde having approximately the same molar mass. Let us take the given here, ethanol having the molar mass 44 gram per mole, its boiling point is 21 degree. The ethanol having approximately the same molar mass 46 gram per mole, its boiling point is higher than ethanol, while methanoic acid having the same molar mass but it is the highest boiling point. What is the reason here? Two molecules of carboxylic acids, as you see in the figure, are held together by two hydrogen bonds at the carboxyl group of each molecule. So what do we have here? Hydrogen bond between the fairly positive hydrogen atom and a lone pair on the fairly negative oxygen atom. What do these two hydrogen bonds form? They form a dimer. This explains the reason of methanoic acid having a higher boiling point than ethanol, where two molecules of ethanol have only one hydrogen bond between them. Do you remember what did we take in chapter of ethanol? And while ethanol does not have any hydrogen bond. Now let's move to the reactivity of the carboxyl group. The carboxyl group shows in this figure the common characteristics with the hydroxyl group on one hand and the carbonyl group on the other hand. When a proton is released in the carboxyl group, it gives carboxylic acid its acidic nature. In general, carboxylic acids undergo acid-base reactions and substitution reactions when the OH is replaced by one atom or group of atoms to give acid derivative, as you will see in the second session. Now, how carboxylic acids behave with indicators. They turn the color of bromothymol blue to yellow and the blue litmus solution to red. Now let's continue the second objective, which is some chemical reactions of carboxylic acids. The chemical reactions are: the first one, reaction of vinegar with a marble piece. The second one, reaction with water or ionization in water. The third one, reaction with a strong base. The fourth one, reaction with a metal. And the last reaction is with alcohol, where do we have esterification. Let's start with the first reaction of vinegar with a marble piece. What is a marble? It is made up of calcium carbonate. What does vinegar contain? It contains ethanoic acid solution. So the reaction will be between calcium carbonate with ethanoic acid. As you see in the figure here, what do we get? We get effervescence of carbon dioxide gas that makes clear lime water turbid and formation of a salt. This salt, we name it calcium ethanoate. And how do we write the formula of it? We multiply the ethanoate ion by 2 in order to balance the charges of the negative ion and the positive ion, calcium ion, which is 2 plus. Now the second reaction is with water or ionization in water. Let us recall what did we take in the unit of acid base. We have carboxylic acids are weak acids. They are partially ionized in aqueous solution according to the following equation. The carboxylic acid with water in a reversible reaction, you get carboxylate ion plus hydronium ion. Let us recall also together the expression of the acidity constant of the conjugate pair acid-base RCOOH, and the RCOO- is Ka equal to the concentration of the conjugate base times the concentration of hydronium ion, both formed at equilibrium, over the concentration of the carboxylic acid remained in the solution at equilibrium. Let us take an example of ethanoic acid. Ethanoic acid is a bronzed acid. It donates the H plus to the water molecule. And what do we get in the solution? We get hydronium ion that makes the solution acidic with the formation of ethanoate ion, which is CH3COO-. The third reaction is with a strong base. Let us take an example, sodium hydroxide, and let us recall weak acid with a strong base. You get salt plus water, and here the salt is basic salt. So example of this one, here we have propanoic acid. Propanoic acid, it is also a bronzed acid. It donates the H of the hydroxyl group here to the OH minus, and it forms in the solution water with propanoate ion. Now, what about the Na+? Na+ is not written in the equation because it is a spectator ion, but the salt is named sodium propanoate. And pay attention here, if we ask you, calculate the mass of the salt produced or formed, you have to calculate the molar mass of the sodium with the propanoate ion. Don't forget this one. And also we have the Kr. The constant reaction here is equal to the concentration of the conjugate base RCO minus over the concentration of the carboxylic acid times the concentration of the OH minus. The fourth reaction of carboxylic acid with a metal, let us recall together the reactivity of metals with acid. Here you have the table. We have the metals that react with acids. They are more reducing than hydrogen, and the metals that do not react with acids, they are less reducing than hydrogen. So carboxylic acids react with metals which are more reducing than hydrogen. We have butanoic acid, an example, with magnesium as a metal. What do you get? You get the salt, which is magnesium butanoate plus the formation of hydrogen gas. And we have to write balanced equation. So what do we have here? We have to multiply the butanoate ion by 2, and you get here butanoate ion plus the magnesium ion that has a charge of 2 plus. So the charges are equal here, the 2 minus and a 2 plus, and you get a balanced equation by multiplying butanoic acid by 2. Now the last reaction of carboxylic acid with alcohol, which is esterification. Esterification, as you know, is the reaction between a carboxylic acid and an alcohol. It is a reversible reaction. Carboxylic acid plus alcohol, it will give ester plus water. Now, let's see here what's going on. We have the OH of the carboxyl group. It reacts with the H of the hydroxyl group of alcohol, and water is eliminated. It will be formed in the product with the formation of ester. So example of this one, propanoic acid plus ethanol, you have reversible reaction. You will get the ester, which is ethyl propanoate plus water. Finally, I hope that all of you found interest in this session. Thank you for your attention.